So we're expanding to the power of 4 here. So 14641 is what we are going to use here. And if we have a look, let's have a look here. So we're going to do 1 minus x to the power of, let's make this go, that can start at 4, and then we're going to have 1 minus x to the power of 3 times, and the other one's x squared, and then we've got 1 minus x squared now, and this is x squared squared because it's going up. And you'll see that anything bigger, anything further we go, we will get bigger terms. I'm really looking at this. This is going to be x to the power of 4 when we do the constant in that bracket times x to the 4. But the highest, x squared times x4, will be x to the power of 6. So we don't need all of that, but we need some of it. So we're going to do that term. All right. So then when we're looking at this first term again to the power of 4, so 1... let's make that x get bigger. So let's go 1, 4, 6, 4, 1. That's just the first bracket expanded. And then when we do this next one, we've got 4x squared times, so I'm just putting those two together, times, now this would be 1331. We only need to go up to the x squared term because x squared times this front x squared will be x to the 4. So I'm going to get 1, 3, 3, and then that's all I need. So I'm going to just dot the rest. We don't need the rest. And then in the next term, it's 6x to the 4, and I don't need any other of the terms because I only wanted the times 1 of the expansion of 1 minus x squared, and the rest will be higher than x to the power of 4, so we don't need those. So putting what we've got together at the moment, we've got a 1, that's all we've got there. In terms of x, if we look at our x's, we've got a negative 4x. Is that it? Yeah, that's it. Alright, negative 4x. So see that this one, the smallest, is an x squared term. So here we've got a positive 6x squared, and we've got a positive 4, so positive 10x squared there. If I look at the x cubes, we've got minus 4 here for x cubed and minus 12. So minus 16x cubes. Hopefully we are on the right track. Alright, x to the 4s, we've got a positive x to the 4, and this would give us a 12x to the 4, so that's 13x to the 4, and then another 6, so I'm saying a 19x to the 4 here. And then of course everything else will be bigger powers of x, so I'll just put dot dot dot. So it says just as far as the term containing x to the power of 4. Alright, will that help us with the next one or not? Possibly not, so I'm going to rub that out. Okay. Part B is expanding again with a, so there's a term, we usually try and put the x's together, so let's put these x's together, and not only do we do that, but we could also think of it as 1 plus x, 3 plus ax, if we, so think of that whole thing together to the power of n there. So it's an x outside of a 3 plus an ax. That might be easier. So when we expand that, the coefficient of x squared, we're looking for the coefficient of x squared because that's 0, and the coefficient of x cubed. Okay, so let's just expand it a little bit. So we're going to get n choose 0, which is 1. Then we're going to get n choose 1, and we're going to get one of these. Then we're going to get n choose 2, and we're going to get square both of these. And then we're going to get, actually we don't need to go any higher, I think. What are we looking for? The coefficient of x squared. So you can see that the smallest term, I'm going to put dot 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 there. If we're looking for the x squared term, one of them is going to be gotten from doing x times that x. So for the coefficient of x squared, let's have a look at that. So it would be n choose 1, which we know is n, so I might just write n there instead. Oops, that didn't rub out. There we go. So we're going to get n choose 1, and then x times x is x squared, but there's an a there, so I'm going to get na. Or I could get, so if I expand this out using the square, you see we would have a 9. 3 squared is 9. We would double the product, so 6ax, and then we'd also have a squared x squared. So that's if I expanded that out. So if I've got an x squared out the front, you can see I'm going to get the x squared term just from multiplying the n choose 2 by 9. And that's the only x squared term I'm going to get there. So if I know that that term, the coefficient is 0, so that's going to equal 0, then I need to solve for a, I think. Okay, so we're solving for a first. So let's just expand this a bit. So here we're going to get n factorial on n minus 2 factorial, 2 factorial. And there's a 9 out the front, and that equals 0. So I can at least multiply the bottom by 0. Oh no, I can't do that. So I'm going to make them equal to each other. So n choose a, na must equal minus 9 n minus 1, because that gets rid of the n on 2 factorial. On 2. So what have I done? I've just said n factorial on n minus 2 factorial. I've just tried to simplify that. So that's n minus 1 and then n minus 2 factorial on n minus 2 factorial. Cancelled those two. So just n minus 1. So I'm just putting that on the other side, and then I'm going to make a the subject. So you can see a, I'm dividing by n. So we'll just get rid of that n that was already there. So I'm getting that. So my a value is equal to 9 lots of 1 minus n's on 2. So that's a, if I just put the negative through that bracket, I get that for my a value. So let's just remember that so that we can use that. So a is 9, 1 minus n on 2. And then the coefficient then of x, I shouldn't have rubbed that out, of x cubed. Is that what we want to find? So then that means the coefficient of x cubed. If we're looking for our x cubes, I may need, do I need another term? Yeah, I better put another term in there just in case, because I was finding x squared before. So what would our n choose 3 be? So that x is now cubed, and this 3 plus ax is also cubed. Alright, so where are we going to get our x to the power of 3's from? So none of these gives us, this is just an x, that's an x squared. Alright, but this one, which we said was 9 plus 6ax plus a squared x squared, that bit there with an x squared and an n choose 2 at the front. So if I'm doing x squared, I'm going to do times 6ax to get my x cubed. So what am I doing? I'm taking the n choose 2, I'm multiplying by the 6 and the a to get my x cubed from that one. Now from this one, so we've got the n choose 3, we've got x cubed, and then this, if I expand it using maybe 1, 3, 3, 1, so if I get one lot of the first term, let's say cubed, 1, oops, there we go, 3 times 3 squared ax, 1, 3, 3, now it's 3 to the 1 ax squared. Alright, so anyway, dot, 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 dot. So remember, I've got a cube, oh, I've already got a cubed out there. So I'm not even interested in these ones. I'm just interested in that one. So 3 cubed, which is 27. So I'm also going to get n choose 3 and times 27, 3 cubed. So that's going to be my coefficient. Now, remembering what the coefficient, what a is equal to, we can say this is n factorial. Let's do this. Oops, n factorial. So we know n factorial on n minus 2 factorial, 2 factorial, times 6 times what's a? A is 9 lots of 1 minus n's on 2. So actually I'll just make that a 3 plus n factorial n minus 3 factorial, 3 factorial times 27. So this 3 factorial we know is 3 times 2. So if I take the 3, just put the 2 there and cancel that, divide that by 3, that's a 9 there. Oh goodness. Alright, so simplifying 9 factorial on 9 minus 2 factorial, we know that it's sorry I said 9 instead of n, so n minus 1 and then n minus 2 factorial, so that cancels that one out. But it's still on 2, 2 factorial is 2. Now what have I got left here? 3 9s are 27, lots of 1 minus n's. And here I've got n minus 1, n minus 2, and then n minus 3 factorial on 3, n minus 3 factorial, so that cancels. And then I've also got my times 9 on 2, I think, all together there. So everything's on 2, so actually I could put these things together. Remember, this is just now algebra, but we'll keep going. So over 2, I've got n minus 1. I might put n minus 1 squared and put a negative in the front. So I'll put that negative back out there. So we'll have a minus 27 on 2. So it's all on 2, so keep going. And this will be a plus 9 n minus 1, n minus 2. If we put it all together there. So I could factorize by the n minus 1 on 2, actually 9 n minus 1 on 2. They both have that in common, right? They both have that in common. So if I show you, that's a 9, that's an n minus 1, and then on the 2. So that's just an n minus 2 left for that one. In this one, it's in the first term, it's a minus 3, because 3 9s are 27. I've got the n, and I've got one of the n minus 1s. There'll still be another n minus 1 there. So putting that all together, let's see, it's a lot of work. Here would be n take away 3n, so minus 2n. And we've got a minus 2 plus a 3, so 3 minus 2 is 1. So 1 minus 2n here. Alright, or you could put the minus out the front, but that looks nice. So that would be the coefficient of x to the power of 3.